Welcome to Climate Central's monthly climate brief. Climate Central is a nonprofit, non-advocacy organization of scientists and communicators. Our team researches, reports, and creates resources for storytellers. Climate Central's content is straightforward and visually compelling and includes data to make the links between extreme weather events and human-caused climate change. Today's webinar, it was going to give you an overview of 2026's weather and climate through May. Leading our discussion is Dr. Zach Labe. Zach's interests explore the intersection of climate impacts, future scenarios, extreme events, early warning predictions, and applying novel data science methods like machine learning. In addition to these research areas, he is very passionate about improving science communication and data-driven visualizations. Zach was a scientist at NOAA's GFDL before joining Climate Central last spring. He will be leading our presentation. Also joining us today are Dr. Ryan Truchelot from Weather Tiger and Callie Van Balen from Climate Central. I should know that. I work with her every day. So over to you, Zach, and go ahead and get us started.
Thanks for the introduction, Jen, and thank you all for joining us today. There's a lot to run down with big headlines about El Nino and the tropics today, and we'll try to cover that all in this latest briefing. So we'll get started. What are we looking at today? We'll be doing a rundown as usual on the current global and US climate numbers from the last month and taking a look at Boreal Spring 2026. We'll also spend a lot of time on the latest on El Nino, which I'm sure there are lots of questions about the latest El Nino advisory issued and what that means in terms of impacts. And then as Jen mentioned, we're having our special guest today talk about the upcoming hurricane season, and I'm sure we'll touch on the connections between the current El Nino and what that might mean for the hurricane season. But first we'll get started as usual with what the climate moment of the month was. And the climate moment this month was a big record. It was a new all-time record high for the month for carbon dioxide at Mauna Loa Observatory, which is located on a high mountain peak in Hawaii. And so every time of year around the month of May, we reach a seasonal cycle at its maximum. This is due to the greening of the northern hemisphere, where vegetation that is now greening across the high latitudes, especially in the temperate and boreal forests, as they start growing, they suck up some of that CO2, which draws down CO2 just a bit during the summer and into the fall season. So every single year, usually around the month of May, in the middle of the month, we reach a maximum in that seasonal cycle of carbon dioxide. The seasonal cycle is normal. The problem is we're emitting more carbon dioxide than we can take in from natural sinks. And so we are seeing a long-term increasing trend. So here's showing that classic healing curve graphic where you can see the long-term rise in the concentration of carbon dioxide, which of course is directly linked to human-caused climate change and the warming of our planet. So yet again, it's another year with a brand new all-time record high at Mauna Loa. And so now we'll connect this to what was the latest numbers for the month of May globally. So globally, it was the second warmest May on record. So the map is showing a breakdown of where you can find areas that were much warmer or cooler than normal last month. Anywhere in that sort of really dark red color indicates that that area was record warm for the month of May. So if you take a look at a lot of tropical regions across the Pacific were record warm during May. That extended all the way to the coast of Mexico, where there's been a very persistent marine heat wave in that region. It's also been very unusually warm across parts of the Southern Ocean. So take a look at the Southern Atlantic and the Southern Indian Ocean, where we can see record warm conditions for the month of May. Over global land areas, it was the fifth warmest, but over global ocean, it was essentially statistically tied for the warmest May on record for global sea surface temperatures. So in addition to the current El Nino, which we're going to talk a lot more about, the oceans just overall globally are extremely warm, especially in the southern hemisphere right now. One of the highlights from last month, in particular at the very end of May, was a really historic heat wave across much of Western Europe, especially in the UK. In fact, 23 weather stations broke the national record for the UK for the May maximum temperature, which is now 35.1 degrees Celsius. So what you're seeing here is an animation on the left-hand side. It's showing the temperature departures, so showing where it was much warmer than normal on the left. And on the right-hand side is a tool from Climate Central called the Climate Shift Index, which can directly link those daily temperatures to human-caused climate change. So where you see those darkest red colors, that means temperatures during that day were made at least 5 times more likely due to climate change. So I encourage you to check out the Climate Shift Index every day of the year globally. You can find this information, and we can see it really highlight really some of these unprecedented heat waves like we've been experiencing recently. Now taking a look, as I mentioned earlier, it's very warm across the global oceans. So this is showing those temperature anomalies for the month of May. Again, red areas are warmer than average conditions. We can see stretching across most of the ocean areas, especially in those mid-latitude regions of both the northern and some southern hemisphere. You can see those bands of really, really warm, dark red ocean temperatures. I've also highlighted that box where sort of we monitor El Nino there in the tropical Pacific, and we'll turn to that at the very end of the presentation. And again, overall, if we take a look at daily global mean sea surface temperatures for the middle of June, they are at record high levels. So it is already quite warm, and we expect these conditions to continue through the rest of 2026. Zooming in now, taking a look at the US in May. May was somewhat unremarkable compared to their earlier start this year in 2026, where we saw a lot of record warmth. But consistently, we're seeing more of those warmer than normal conditions across the western half of the United States. So that continued in the month of May. Similarly, for the pattern we've been seeing much of this year, some of those cooler temperature anomalies were actually found across parts of the Great Lakes, stretching into the Ohio Valley and parts of the Northeast, where we can see Pennsylvania and New York in particular were a few degrees below normal for the month of May. Overall, for spring, it was quite warm. May was a bit of the outlier in that 27 states recorded one of their 3 warmest springs on record this year. So overall, particularly for March and April, it was quite warm across the US. For precipitation, we have some good news actually to share. After starting off a very dry start to the year across all of the lower 48, we finally saw some higher precipitation anomalies across the Southeast, which has been really suffering from a severe drought for much of the year. Overall, though, 2026 still ranks as the 6th driest start to the year for that January to May period. But we can see that finally we're seeing some of those wetter conditions return to the Gulf Coast, and more precipitation is in the forecast associated with tropical conditions from the Gulf. On the right-hand side, you can see there's sort of just a time series of the long-term trend in the amount of average precipitation for the lower 48, which is slightly increasing over time. So checking in on the latest drought monitor, as I mentioned earlier, we finally saw some drought relief across the Southeast. That was also reflected in the drought monitor with some improvements across some of those southern states. However, we can still see the drought continues for areas across Florida, Georgia, South Carolina, extending up into the mid-Atlantic region where extreme drought conditions are prevalent. We also see much of the same across the West, where there's wide, expansive areas under drought. In fact, 45 states are experiencing at least some area that's having moderate drought or worse conditions, affecting over 150 million people across the US. Very similarly, we're very much at the end of sort of the snow season across the West, and all of those basins remain well below normal in response to that snow drought that we discussed earlier this year, especially across states like Utah, Colorado, into Wyoming that had just really record low snow conditions. Overall, though, as from that previous drought monitor, you might have noticed that just the really widespread nature of how dry it is across the US, despite some of those wetter than normal conditions during the month of May. So we can take a look at other drought metrics to really understand how does this compare to the historical record. So taking a look at this graphic, so this is called the Palmer Drought Severity Index, which sort of takes a look at how unusually dry or wet conditions are, especially based on things like temperature, precipitation, soil conditions. And what this is showing is the average index across the lower 48 from the 1895 on the left all the way through the current year 2026 on the right. So what I want to highlight here is that actually based on this drought severity index, conditions were the second worst on record and basically statistically tied as bad a drought conditions on average across the US as the Dust Bowl there in 1930s. That also continued from last month where we saw again historic conditions for the Palmer Drought Severity Index. So to me, this really highlights the nature of how unusually expansive those drought conditions are across the lower 48. Taking a look at the springtime over the last 3 months, if we look at every March, April, May globally, 2026 is the third warmest on record. So this graphic is showing the global mean for the boreal spring season from 1900 on the left all the way through 2026 on the right. So we can see that, of course, long-term increasing trend, which 2026 is very much in line with that globally. Here is taking a look at conditions closer into the US, where I mentioned that spring was unusually warm. In fact, spring 2026 was the second warmest on record. This was the hottest since the historic spring in 2012. What you're taking a look at here is temperature percentiles for those 3 months. Areas in that dark red color indicate that they observed a record warm spring this year. So you can see almost the entire states of Arizona and New Mexico had record warm spring conditions. But much of those historic warm conditions spread actually across the entire southern half of the US, including parts of Florida, including parts of North Carolina and Virginia. So overall, it's been a very warm start to the year. This is also in line with it's been just a historic stretch of warm conditions. In fact, if you look at chunks from the last 6 months to the last 60 months, all of those temperatures on average are the warmest on record for the contiguous United States. So we are in a very much in a historic warm stretch of conditions. So what does that mean coming forward into the future? So taking a look at the next 3 to 4 weeks, we can see much of the same. So we can see warmer than normal conditions more likely than not across the western half of the US. And we can see those cooler than normal conditions potentially likely across parts of the Great Lakes and Northeast. So looking at the month of June, going into early July, we're seeing very much a similar pattern of what we observed in May for the distribution of temperature anomalies. Looking at precipitation, we might see an early start to the monsoon season across parts of the southwestern US with a bit of an chance of above normal precipitation in those areas. Also, the Northeast may see a welcome return to some wetter than normal conditions. Again, taking a look at the latest outlook from the NOAA Climate Prediction Center. For the overall during the summer season, what's happening sort of in the longer term trend? So in addition to that climate variability, those year-to-year changes, there's also long-term changes happening linked mostly to human-caused climate change. So this is taking a look at those change in temperatures across the lower 48 since 1970, where we can see most of the US has warmed. The largest temperature trends for the summer season have been across the western half of the United States. You might notice also across the central US is a bit of this warming hole feature, which is both a combination of natural climate variability as well as maybe some human influence and potentially even land conditions related to corn sweat. So it's always interesting to take a look at the regional distribution of how temperatures have changed over time. So now the big question that I'm sure everyone is wanting to hear more about is let's do a check-in on the latest for El Nino. So again, for those not familiar, what is El Nino? So El Nino is a natural climate pattern that is really important in our climate system. It's most commonly associated with warmer than normal sea surface temperatures in sort of the central Pacific Ocean across the tropics. So this is taking a look at the change in sea surface temperature anomalies since the start of May all the way through current month of June. So what I want you to see here is you're probably noticing an increase in those dark red colors. That's sort of the onset of El Nino conditions. The box outlines we're seeing here, those are areas where we focus on key monitoring metrics to try to understand the intensity of El Nino. So just again, to orient yourself on the right-hand side of this map, that's taking a look at Central America and South America. So we can see very much that El Nino conditions are here in terms of looking at the spatial pattern we look for El Nino. In addition to that ocean warmth, El Niño also has important connections to the atmosphere. So these warmer than normal sea surface temperatures, they also affect sort of where you can find thunderstorms and convection across the tropical Pacific. And then that leads to far-reaching effects. We call them teleconnections, meaning that those changes in atmosphere and oceanic conditions in the tropics around the El Nino region also have far-reaching effects on climate impacts all around the world, which is why we focus so much on trying to understand this natural climate pattern. So let's take a look at ocean temperatures in one of those boxes, one of those key monitoring areas, which we call the Nino 3.4 region. So this graphic is showing sea surface temperatures in that box for 2026, that's the yellow line, relative to all the other years since 1982. So looking at those squiggly lines there. So what you might notice is that current conditions as of yesterday are record warm for this time of year. This is both a combination from the long-term warming of the tropics in addition to the El Nino conditions, which are boosting those sea surface temperatures even higher. So as you can see, we're already well in line with El Nino forming, and typically El Nino conditions reach their maximum strength right around the boreal winter season. So we'll definitely be keeping an eye on this graphic and how it evolves over the next few months. So the latest conditions officially from the NOAA Climate Prediction Center just issued this past week say El Nino conditions are present. And there is a 63% chance of a very strong El Nino for this upcoming winter. That would rank among the largest intensity El Nino events in our historical records dating back to 1950. So is there a potential for a very high impact and unusual event to occur? We can also take a look at this in the probabilistic sense. So what that means is taking a look at the likelihood of different strengths of this El Nino, because there's still some uncertainty in the forecast. So what these bar graphs are showing is the likelihood for different intensities, such as a strong El Nino, a very strong El Nino. You might have heard the word super El Nino in the news. So officially, NOAA uses the term very strong. So they're sort of synonymous here. So what we can see if we look at the season, so SON is referring to September, October, November. So by boreal sort of fall and going into the winter, we expect more likely than not conditions of a very strong El Nino, approaching a likelihood again of 63% during the months of November, December, January. So again, all indicators here show that a strong or very strong El Nino event is likely coming for this year, which of course will have impacts. If we take a look at what goes into some of those probabilistic forecasts from the Climate Prediction Center, they took a look at things like seasonal forecast models. So you might notice here a lot of letters here and acronyms. Those are referring to different models that are run to try to understand seasonal conditions in advance. And one of the key metrics that they look at is, of course, El Nino, and they monitor sea surface temperatures in that key monitoring box, that Nino 3.4 region. So all of the individual lines here are referring to individual model runs. The different colors are the different models which are run by different scientific institutes. And so you can see they all agree that conditions for El Nino will continue through into early next year. We can see that there's some spread in the forecasts. Sort of the range of uncertainty is somewhat substantial for how intense this El Nino might get. But overall, the model mean, the average across all of those forecasts, is showing a very strong El Nino event is in line with these forecasts. So in addition to those teleconnections, those climate impacts around the world, El Nino also plays an important role in the global climate system. So we know that temperatures are warming in the long term linked to human-caused climate change, and El Nino acts to boost those temperatures temporarily, increasing the anomaly even more. So one of the metrics that we're trying to better understand for later this year is how hot are global surface temperatures going to get? So again, these are using those same forecast models, those seasonal models, and taking a look at their forecasts. So here they're run starting in the beginning of June. And on the right-hand side, that's the projections going forward into the future. And so this is showing the global mean surface temperature anomaly relative to pre-industrial conditions. So you can see the average there is that solid red line with the scatter or the markers. And so they're indicating the average across the models that we are getting close to 1.8 to 1.9 degrees for the global mean above pre-industrial levels for months potentially later this year. So this would indicate a very high likelihood that we will be breaking new global temperature records in just a few months later this year. And you can also notice there's quite a large range in how hot some of those forecast models are getting later this year. So we'll definitely be keeping a close eye on this metric. And as I mentioned before, El Nino has those sort of far-reaching climate impacts. Some areas are wetter than normal. Some areas are drier than normal. I do want to note that the connections between El Nino for these regional impacts are most significant for the December, January, February period. So on the left-hand side is showing a map of where you might expect during a typical El Nino to have a higher likelihood for some of these drier conditions or wetter conditions. But I do want to point out that every El Nino is unique. So even though El Nino is a really important predictor for seasonal forecasts, every event is different. So while it might make it conditions more likely, let's say for a drying across the Amazon, that doesn't necessarily mean that that is exactly what's going to happen. As we know, the climate system is very complicated. There's other pieces of the puzzle that impact regional climate variability, but El Nino just makes some of these conditions more likely than normal. So, what's our takeaways from the latest El Nino update? I know we're hearing a lot of scary things in the headlines of the news, but here's sort of our grounded takeaways. And that El Nino conditions are present, it has developed, and a potentially historic event could unfold this year. We also believe that record-breaking global temperatures are increasingly likely later in 2026, again linked to El Nino boosting those conditions on top of the long-term warming trend. And then lastly, although El Nino raises the odds of certain impacts like a drying or wetting or cooler or warmer than normal conditions over different areas, again, every El Nino event is different and there's still some uncertainty in the forecast. So we'll be providing monthly updates here on the briefing on all of this. So I'll come here to my conclusions for this part of my take on the briefing. So overall, global warmth continues even as El Nino is just starting to unfold, where May was ranked as the second warmest May on record globally. We're also seeing across the US widespread drought conditions continuing, with more than 30% of the lower 48 experiencing a severe drought or worse right now. Spring was also quite unusual across the US. In fact, if we take a look at NOAA's US Climate Extremes Index, which tracks things like the number of extreme temperature, precipitation, and drought days, it was the highest level on record for spring 2026, and that's 145% above normal. And overall, over the next 4 weeks, we expect much of the same, where warmer than normal conditions are more likely, especially across the West. And I just want to highlight, so our next briefing will be on July 15th. We'll have a special report on a mid-year update for the number of 2026 billion-dollar disasters we've experienced so far. And so now I want to transition into our special feature for this month's briefing, and that's taking a look at the 2026 hurricane season outlook and the drivers that go into it. So I'm really excited to introduce Dr. Ryan Truchelette, who's the co-founder, president, and chief meteorologist of Weather Tiger, who will give you the rundown on the current hurricane season conditions. And I will turn it over to him.
All right. Well, thanks so much, Zach, for that masterful update on global climate and for walking through the El Nino forecast, because that's really going to be something that is very relevant to hurricane season 2026. I think people get very nervous when they hear the word super used in connection with any meteorological phenomenon. But we're going to walk through what that means for risk profiles for the Atlantic hurricane season ahead. So we're coming off really a brutal last decade of hurricane activity with a respite for the continental United States in 2025. So as I'm looking ahead to the 2026 hurricane season, I'm asking the question of, if lightning cannot strike twice, will we be as lucky in 2026 as we were in 2025? So let's walk through. There we go. There's this is a map of the 10 major hurricane landfalls. We're talking category 3, 4, or 5 hurricanes on the Saffir-Simpson hurricane wind scale that have made landfall on the United States Gulf Coast since 2017. In
Ryan,
fact,
I think we might not be seeing your slides. Sorry to interrupt.
oh, okay. Okay. 10 major hurricane landfalls along the Gulf Coast since 2017 in an 8-year period. That's historically unprecedented. We've never had that many storms make landfall in such a limited section of the U.S. coastline over that short of a time period. And collectively, just these 10 major hurricanes have done $600 billion of damages to the continental United States. Collectively, the last 10 hurricane seasons have done about $750 billion worth of damage. So the stakes of predicting hurricane activity are very high in both economic and, of course, in human terms. So coming off that brutal stretch from the mid-2010s into the mid-2020s, the 2025 hurricane season was notably quieter for the continental United States. This is a map that the National Hurricane Center puts out after the season ends of all the tropical storm and hurricane tracks in the Atlantic, Caribbean, and the Gulf. over the previous year. And what you'll note from this map is that while there was a good amount of hurricane activity in 2025, it predominantly took place in the eastern Atlantic Ocean and the tropics and kind of the west central subtropical Atlantic. Bermuda had repeated hurricane threats, but we really didn't have anything impactful near or over the continental United States. Just one named storm landfall in the Carolinas in July. Of course, there was Hurricane Melissa, which made landfall as a Category 5 hurricane in Jamaica in October of 2025, which is actually the strongest tropical cyclone on record anywhere in the Atlantic Basin, but it did avoid the continental United States. So if we take a look at how lucky were the continental United States in 2025, the answer is very lucky indeed, because it wasn't a quiet hurricane season. Hurricane forecasters talk about a quantity called accumulated cyclone energy, or ACE. A typical hurricane season over the last 75 years averages a little over 100 units of accumulated cyclone energy per season. And that kind of more heavily weights stronger or longer-lived hurricanes. So in 2025, accumulated cyclone energy was about 130 units of ACE versus that 105 ACE normal. Primarily, that was driven by 3 Category 5 hurricanes, which ties the record for most in the Atlantic Basin within one hurricane season. Now, if we scale that number, however, by how much ACE occurred near or over the continental United States versus how much ACE occurred overall anywhere in the Atlantic, well, in a typical hurricane season, about 4 or 5% of total cyclone energy happens near or over the continental United States. That can be as high as almost 20%, as it was in 1985, or as low as 0.2% as it was last year, which is the lowest on record. So we did have quite a bit of hurricane activity, but we were very fortunate in that hurricane activity developed generally at a distance from the continental United States and then was steered out to sea for the most part, or in the case of Melissa, unfortunately, caused devastating impacts in the Central Caribbean. Now, if we take a look at longer-term variability in landfalls, and I'm very concerned with impacts and landfalls because it's what matters to people. If we go back and we look at the historical record going all the way back to 1900, this figure shows the average number of landfalls, named storms in blue, hurricanes in red, major hurricanes, those are Category 3s, 4s, or 5s in gold. These are 10-year averages, trailing averages going all the way back to 1900 and all the way up to the present. So there's really no long-term overall trend in how many tropical storms or hurricanes are making landfall over the last 125 years. But what we do see is extreme variability on both interannual scales from year to year or interdecadal scales, these longer periods of busier or quieter or more or less impactful hurricane seasons. We also see that there is a possible trend towards a higher proportion of hurricane landfalls happening at Category 3 intensity or above. So all these 10-year averages, if you go back to the 2015 through 2024 period, we never averaged a higher number of named storms, hurricane, or major hurricane landfalls over that 10-year period, going all the way back to 1900. So if the last 10 years or 12 years have felt really brutal in the tropics, you're not wrong from a historical perspective. It has been unusually impactful, especially in terms of those major hurricane landfall impacts. Averaging 1 per season is not normal. I mean, typically you have about a 40-45% chance of a major hurricane landfall in the continental United States in a given hurricane season. So what is normal in the Atlantic anyway? Well, Atlantic hurricane season runs from June 1st through November 30th, but not all months within that hurricane season are created equal. This on the top panel here is an average of the amount of ACE that's happening within a 2-week period over the course of hurricane season. And the bottom panel shows the average number of developments of named storms, hurricanes, and major hurricanes per day within 2-week windows as well. So what we see is that in the Atlantic Basin, we call the hurricane season climatology strongly peaked because over half of hurricane activity in the Atlantic in terms of ACE actually happens just in the month of September, which is the busiest month of hurricane season. And as we can see in the bottom panel, our major hurricanes in gold mostly happen in August, September, and October. But if we change up our view a little bit and we make it a little more human-centric, and we talk about landfall climatology, hurricane season is a little more smeared out. That big mountain, the peak in September, is still the busiest time of hurricane season from a landfall perspective, but we have more activity kind of on at the beginning and the end of the season than just overall climatology would indicate. So, and in fact, as we go through June and into July, we kind of have a plateau where between mid-June and early August, we have a roughly analogous amount of landfall activity. We increase into the peak of the season, and then we have a tail that extends through October, and we still have a fair number of major hurricane landfalls in October. But I want to draw your attention right now to kind of this early peak around mid-June that we see, especially in the terms of named storms in blue. We see a little bit of a secondary peak with U.S. impacts. So, and just in time, right on cue, we have the first National Hurricane Center advisories for the season coming out today for potential tropical cyclone number 1. Potential tropical cyclone number 1 is a bit of a weirdo in the fact that it's actually located over land right now in South Texas with convective activity, thunderstorms extending along much of the western and central Gulf Coast and into the deep south. Here's the 11 a.m. advisory track from the National Hurricane Center. You can see that while the center of this low is currently over South Texas, it is expected to move over the far northwestern Gulf over the next day and a half or so and intensify, get better organized, and possibly become Tropical Storm Arthur sometime tomorrow. Now, Arthur, or if it becomes a tropical depression, Tropical Depression 1, or if it remains a potential tropical cyclone, all the impacts are basically going to be the same here. And this isn't something that's really out of turn for climatology. Here's a figure that shows all of the impacts on the Gulf and southeastern coasts that happened in the month of June, going all the way back to the start of our historical records in 1851. And as you can see, the Texas and Louisiana coasts, even early in the hurricane season, are no strangers to landfalls. Most of these landfalls are at tropical storm intensity, but you do occasionally have some hurricanes forming and making landfall on the western Gulf Coast in the month of June. Usually not major hurricanes, however. There's only one historical major hurricane landfall, Aubrey, in 1957 along the Texas and Louisiana border. So while prospective Arthur may come in near that point, near that Texas-Louisiana border, it's not going to be at hurricane intensity. It would be a lower-end tropical storm at most. But we shouldn't sleep on lower-end tropical storms because they can have outsized impacts in terms of precipitation, flash flooding, and river flooding. And that's an underestimated hurricane threat and impact. People think of hurricanes and tropical storms as wind or surge threats, and they don't prepare in quite the same way for the prospect of heavy rainfall and flooding. This is a map from the National Weather Service's Weather Prediction Center, excessive rainfall outlooks over the next 3 days. And these areas highlighted in red are the regions where we're at the highest risk of flash flooding. So for the southeastern Texas coast, across Louisiana, south central Mississippi, and into west central Alabama, these are the areas that can expect 4 to 8 inches of rainfall and potential flash flooding to go along with that over the next few days. And of course, that's not a threat we should take lightly, because if we go back at the and look at the last decade plus worth of casualties due to tropical cyclones in the continental United States, over half of the casualties are occurring due to freshwater flooding, river flooding, flash flooding, mostly in urban areas. So we'll have to keep a close eye on potential tropical cyclone 1 and potentially tropical storm Arthur over the next few days, because while it won't be all that intense in terms of sustained winds, it will be potentially a major rainmaker and flash flood producer over the flood prone and vulnerable Gulf Coast. So with that said, here is a 30,000-foot view of hurricane season outlooks that have been issued so far for the 2026 hurricane season. Both the outlooks that I issue through Weather Tiger, as well as the other well-known outlooks coming out through Colorado State, Dr. Phil Klotzbach, commercial providers, as well as the UK Met Office, European Center, and NOAA's outlooks. So this is going back and looking at the last 10 years worth of outlooks, as well as how those seasons verified how much storm activity we actually had, and the 2026 outlooks issued in May and early June, they're on the far right side of the graph. And what we can see is that in general, in 2026, the average outlook for hurricane season 2026 is less active than any hurricane season since 2015. So that's great news for the storm-addled Gulf Coast and continental United States. And in general, these forecasts have had skill in predicting, in general terms, whether seasons are going to be busier or quieter than average from this forecast period where we're writing our forecast in May and June, looking ahead to the next 6 months. There's some amount of error inherent to the forecast process and inherent uncertainty. But in general, most of the time when hurricane forecasters are projecting a busier than normal year, we get a busier than normal year. And most of the time when we're projecting a quieter than average year, although that hasn't happened much in the last 15 years, a quieter than average season does result. So where does that predictability come from? Why are we able to make those kinds of forecasts? Well, a lot goes into writing a hurricane season outlook. But I'm going to boil it down to just kind of the simplest inputs so you can understand why the 2026 hurricane season outlook right now is shaping up to hopefully be a quieter than average season for the continental United States. So I've highlighted two areas, and as Zach walked you through in the previous presentation, that first area that I've circled in the West Central Pacific, that's our El Nino and La Nina region. The other area that I've highlighted, that kind of kidney bean over the subtropical and tropical Atlantic, that is the region that we watch in the Atlantic Basin that tends to be a good predictor of hurricane season activity ahead. So I'm going to start with El Nino because that's what's generating all the headlines right now. So Zach did a great job of walking you through what's going on with El Nino, what's happening with this transition that we've had out of weak La Nina conditions in winter of 25-26, and now officially with El Nino conditions underway in the Pacific. Why do we care about this from the perspective of Atlantic hurricane season? Well, as Zach mentioned, El Nino is a global climate pacemaker. It really sets the tone for weather patterns worldwide, including the wind patterns that determine where hurricanes develop in the Atlantic Basin, how many form, and how strong they're able to get. So during an El Nino event, we typically have stronger than normal tropical trade winds in the Western Atlantic, particularly in the Caribbean. So in the tropics, typically winds are blowing from the east to the west. During an El Nino year, during hurricane season, those winds are blowing faster than normal out of the east and going to the west at low levels of the atmosphere, first couple miles up in the atmosphere. At the upper levels, 3, 4, 5, 6, 7 miles up in the atmosphere, it's just the opposite. We have upper level winds that are typically during an El Nino out of the west and blowing to the east. So if you have low level winds out of the east and upper level winds out of the west, that's something that tropical meteorologists call wind shear, changing of the direction or intensity of winds with height. And wind shear is very inconducive for tropical development. When you have wind shear of 25 or 30 knots or above, you almost never get tropical development, and it's not a conducive environment for existing hurricanes to get stronger. So these higher than normal wind shear conditions are very typical of El Nino events. And if we look at in previous hurricane seasons, going back the last 125 years, we divide our years into La Nina events, where the Pacific's colder than average, neutral years where we don't have either an El Nino or a La Nina, and El Nino years. There's a big, big difference in the average number of U.S. hurricane landfalls that we see across these years. When there's a La Nina, the bar that's in blue, we're averaging about 3 major hurricane landfalls in the continental U.S. every 4 years. During a neutral event, it's a coin flip. We have about a 50-50 chance of there being a major hurricane landfall in the continental United States. But during an El Nino year, our odds of continental U.S. landfalls decrease to perhaps 1 in every 3 hurricane seasons. So that's a big difference. And if we break things down even further, I'm in Florida. I live in North Florida. Florida is the most commonly affected state for hurricane landfalls. And we break this down into how many hurricane landfalls do we have on average during La Nina's, neutral seasons, and El Ninos. Our Florida landfall rate is about double in a La Nina season versus an El Nino season. And here in the bottom panel, we've broken out our El Nino and La Nina seasons further into stronger and weaker events. And what we can see here is that the average number of U.S. hurricane landfalls declines the stronger that El Nino event gets. So by the time we're looking at some of the strongest El Ninos on record over the past 125 years, basically the top 10% of El Nino events, we're averaging only about one hurricane landfall per season in the continental United States against a baseline of about two and perhaps two and a half hurricane landfalls on average during La Nina years. So this figure shows all the named storms and hurricanes that developed in the 10 strongest La Nina seasons and the 10 strongest El Nino seasons. There's La Nina, there's El Nino. And what you'll notice here is that there's a lot more storm activity in general in those 10 strongest La Nina seasons than in the 10 strongest El Nino seasons. But the place where that activity differential is greatest is in the Gulf and in the Caribbean. So lots of Gulf and Caribbean activity in La Ninas, very, very little in El Nino seasons. And that's because the wind shear tends to be the strongest relative to normal in the Gulf and in the Caribbean. So you can still have hurricane activity in an El Nino season, but it's really disproportionately unfavorable in the areas that are closer to the continental United States. There's a little bit less drop off in, say, the subtropical Western Atlantic areas east of the Carolinas, east of Florida. And of course, you do still get some landfalls historically in even the very strongest El Nino years. The historically strongest El Nino was probably the 1877 event, as far as we can tell. And there were still two landfalls along the U.S. Gulf Coast, two hurricane landfalls in that 1877 hurricane season. So low risk is not no risk, but it does help us greatly to have higher wind shear in place in the Caribbean and the Gulf through the Atlantic hurricane season. Of course, tropical Atlantic temperatures matter too. And if we break out, just as we did with El Ninos and La Ninas, years where that kind of horseshoe is warmer or cooler than average, when there's a colder than average Atlantic, we're averaging only about one major hurricane landfall in the continental United States every 4 years. And when the Atlantic is warmer than average, we're averaging two major hurricane landfalls perhaps every 3 years or so. So there's a big difference in risk profiles there as well. And as I mentioned, there is a great deal of kind of this interdecadal variability. The Atlantic was that horseshoe from across the tropical Atlantic and up the African coast. That's the best predictor of the seasonal activity ahead. It was generally cooler than average in the early 20th century and in the late 20th century as well, up to about 1995. In the mid 20th century and onward since 1995, that area of sea surface temperatures has been generally warmer than average. And here in Florida, going from that colder to the warmer Atlantic regime results in about a 3 times greater historical risk of major hurricane landfalls in the state of Florida. So the Atlantic really modulates our landfall risks as well. And what's going on in the Atlantic this year? Well, we have a situation where there is a strip of warmer than normal sea surface temperatures from the Gulf across the western subtropical Atlantic and heading up towards Western Europe. But the Caribbean, what we call the main development region from Central America east to West Africa, and then the Canary Current up the Northwest African coast, those areas are all looking at sea surface temperatures that are near or slightly below normal. And that's great because that really is the area that has more predictive skill for the year ahead. So, at Weather Tiger, when we're putting together our seasonal outlooks, we're looking at El Nino, we're looking at sea surface temperature patterns in the Atlantic basin, as well as a number of other predictors. We do our seasonal outlooks a little bit differently here at Weather Tiger. Most other sources for seasonal outlooks are updating their forecast every month or every 2 months. We actually run a daily algorithm that takes a snapshot of ocean and atmospheric conditions, corrects for hurricane history, and updates our forecast every day. So you can view that information at weathertiger.substack.com. But our daily forecast right now continues to be for about 75 units of ACE against that 105 ACE unit average. So we're about 25 to 30% quieter than a normal hurricane season would be our baseline expectation for the year ahead. In terms of how that puts us in bottom, middle, and top terciles over the last 75 years, that's a greater than 50% chance that the 2026 hurricane season will land amongst the least active third of seasons since 1950, and about a 40% chance that it would land in that near normal middle third of season since 1950, with a less than 10% chance of landing in that top third of historical activity that has been so pervasive over the last dozen years or so. I also put together a forecast that concentrates more directly on impacts. It looks at, not just how much activity is going to happen in the season as a whole, but tries to localize that for U.S. Impacts and concerns. And again, we're looking at, in an average hurricane season, we have about 5 units of ACE near or over the continental United States. And our outlook for the season ahead is about 3 units for this season. So about 35 to 40% below normal. Still, I do want to point out that there's only about a 20% chance that we get through the upcoming hurricane season without any hurricane landfalls in the continental United States. Most likely we'll have at least one landfall, 1 or 2. There's about a 75% chance that we land in that range. A normal hurricane season, 2 to 3 landfalls is kind of our baseline. So, again, lower risk is not no risk. We're still looking at a probable hurricane landfall somewhere in the continental United States over the next 5 months, although it will not be potential tropical cyclone 1 or Arthur. Just to wrap things up, I will say that, yes, the last decade has been unprecedentedly active for U.S. Gulf Coast hurricane landfalls, other than in 2025. I do think that many of those storms were bumped up a category or 2 because of unnaturally warm waters in the Gulf and Caribbean due to anthropogenic climate change. I don't know that we have changes in terms of named storm or hurricane landfall rates, but the ones that we are getting are likely windier, wetter, and more impactful due to climate change considerations. In hurricane season 2026, I am hopeful that the continental United States will continue to get the break that we had in 2025. I think it'll be a quieter than average hurricane season due to that strong or even super El Nino and the fact that the Atlantic, or the areas that have the best predictive skill, are somewhat lukewarm. But of course, somewhat below risk doesn't mean no risk. Even quieter seasons, such as the 1877 season, when there was one of the strongest El Ninos on record in play, still have 1 to 2 U.S. hurricane hits. So if you want, you can follow our 2026 seasonal forecast models and read my weekly hurricane columns for free at weathertiger.substack.com. So thank you.
Thank you so much, Ryan. So before we do questions, and I know a lot of them are coming in, thank you so much. Kelly's going to do a quick demonstration of a couple tools that we have here at Climate Central. So go ahead and take it away, Kelly.
Thanks, Jen, and thank you all for sticking it out here till the end. I'm going to share with you today 3 tools that Climate Central has that can help you to explore and communicate the risks posed by hurricanes and how human-caused warming is worsening those risks. So the first of those tools is our Climate Shift Index for tropical cyclones. So as Zach mentioned earlier, our climate shift indices quantify the impact that climate change has on various weather hazards, and the tropical cyclone CSI calculates how much stronger hurricane winds are as a result of warmer sea surface temperatures fueled by climate change. So you can access this tool at climatecentral.org/tropical-cyclones. I think Tom will drop that link in the chat for you as well. And that will bring you to this page here, where we have links to subpages for every named storm in the Atlantic Basin. We haven't had any of those quite yet this year, so I'm going to show you the last storm from last year, which was quite devastating, Melissa. So each of these pages has information about the storm and climate change's impact on it. Up at the top, we have kind of basic information about the category of the storm and when we last updated the page. When this is actually happening, the updates are frequent, multiple times a day. And then we get into these kind of cards at the top here that give you kind of key facts about how climate change is impacting the hurricane. First here is the increase in wind speed caused by warmer ocean waters, and whether or not that increased wind speed bumps the hurricane up a category or not. In the case of Melissa, we saw an increase of 11 miles an hour in the wind speed, but it would already have been a category 5 even without that increase, so no category change. Because that wind speed increase is created by warmer sea surface temperatures, we also provide information here about how much warmer than average the sea surface temperatures that the hurricane passed over are, and how much more likely those warm waters were made by climate change. Scrolling down, we have an excerpt here that this kind of user adjustable map from our Ocean CSI tool that includes the hurricane track as well as how much the ocean temperatures it's tracking over are influenced by climate change, as well as the kind of key facts, the same ones that are up here in this box. So if you just want to get the key facts, get in and get out, this is a great thing to do to grab. You can adjust it, zoom in, zoom out, change it how you want it to look, and then download it, and you will have all the key information. Scrolling further down the page, we have information about the peak strength of the hurricane, both in category and wind speed, some kind of more general information about how climate change affects hurricanes, warmer ocean waters, fueling higher winds, warmer air holding more moisture, creating more rain, and rising sea levels boosting storm surges to higher heights and pushing them further inland. We also include information on whether the hurricane rapidly intensified. In the case of Hurricane Melissa, it did. And finally, we have lots of information about our methodology, including links to the peer-reviewed papers that established the methodology for this tool. The next tool I want to show you gets into that last effect of hurricanes, or of climate change on hurricanes that I mentioned, which is raising the platform atop which storm surges arrive. So this is our Coastal Risk Finder tool. This is kind of our flagship tool for exploring sea level rise and coastal flood projections, impacts, and solutions. We've got lots of different data for different scenarios, geographies, and all of it is downloadable either as graphics or as CSV files. And while there's a lot in this tool that's about future projected sea level rise, it's also quite useful for looking at the risks from storm surge events. So coming out of this tool, which you can access at app.climatecentral.org/coastalriskfinder, that'll bring you to this landing page here where you can search for any US coastal location. It's backed up by Google Maps API, so anything you can search for there, you can search for here. But we also include regions, cities, counties, congressional districts, like pretty much every geography you can think of, we've got in here. So I'm going to search for Miami, because we're talking about hurricanes. And that will bring you to this page here, which has this kind of settings panel on the left, map in the middle, and cards on the right. So I'm going to take those kind of one at a time. In the settings panel here at the top, we have a title that tells you what the map is showing you. By default, the map will show you the projected annual flood in 2050. But we can use the select a scenario menu here to switch from looking at risk by year to looking at, the demo gods don't like me today. Okay. Okay, there we go. Sorry about that. You can use that to switch to risk by water level. So if you've got a projection from the National Hurricane Center for a storm surge, you can come in here and set the water level to that height. So say we're expecting a 6.5-foot storm surge in Miami. I set that up. And now on the map here, I see the areas in red that are below that 6-foot water level. I do want to emphasize that this is a bathtub model and is not as accurate to storm surge as physical modeling is, but doing it this way allows us to pre-compute a lot of different exposure data in a way that we wouldn't be able to do if we were doing it in real time. But do not rely on this for projections of where the storm surge will end up exactly. Rely on the National Hurricane Center for that. But anyway, this is a pretty decent approximation of looking at the areas that are below a projected flood level, whether it be from storm surge or future projected sea level rise. The map itself, you can, pan, zoom, everything you're used to. But the real value proposition of this tool are these cards on the right here. And I'm going to focus on one type of these, given the time that we have, which is the risk cards here. The risks show what land, housing, and populations are at risk from the scenario you've selected. Population is broken. We have population broken down by age, race, and social vulnerability as well. And each of these kind of facts has more details if you click into them. So, for example, here we're seeing that 120,000 people in Miami live below a 6.5-foot flood level. If I click on that, it brings me to this page here where we'll get the kind of takeaway message up at the top, reminding you what scenario you've chosen, and then these data visualizations that will show you where exactly that risk is spread out within the region you've chosen. These are downloadable as well as images, and as well as downloading the data behind it as a CSV. And there's lots of information if you come down here on the data sources, methodology, all of that good stuff. But I'm going to move now to our last tool. I do encourage you to check out the rest of Coastal Risk Fund. There's a lot of great stuff in there, but I won't get into it today. The last tool I want to talk to you about is our FloodVision RiskViewer. This is a library of photorealistic visualizations of projected floods taken at street level. So love a map, we all love a map, but it doesn't always communicate the risk to people in as visceral way as seeing an image of projected flooding is. And that's what this library aims to provide. So what is FloodVision? How are we making these images? Basically, you can think of FloodVision as Google Street View, but for flooding. This is the vehicle we affectionately call our flood rover, and on the roof rack, you can see we have a bunch of fancy sensors that help make it work. As we drive the flood rover through coastal communities, we scan the streets to collect stereoscopic imagery, LiDAR data, GPS, fancy stuff. And then we're using a custom API. We can fuse this data together to create a 3D model of the space, which then enables us to generate a photorealistic depiction of flooding with precision, where the water level is very accurate. So I'll just show you some examples of this because they're cool. So this is a evacuation route in Clearwater, Florida. And with FloodVision, we can show what a given flood event would look like along this critical road. This is a flood 6 feet above the high tide line. This is Nathan's Hot Dogs on Coney Island, and here's what it would look like if there was a 7-foot storm surge. This is an EMS station in New Jersey, and here it is with a 6-foot 8-inch flood. So the RiskViewer contains thousands of images along the East and Gulf coasts, just like this. So I encourage you to check it out there in the case of an incoming flood. But we're also able to sometimes generate additional images if you're interested in those. So I encourage you to reach out to us if you're trying to cover a story and think that one of these images would enhance it.